When drilling through a section of soft or unconsolidated rock, such as loosely compacted sand or gravel, it is possible for the formation to break up and collapse into the wellbore. This tends to form a bridge, which can gradually, or in some circumstances, suddenly jam the drill string. Let's look at that once more. To avoid stuck pipe in unconsolidated formations, the following action should be taken into consideration. Be prepared when using a top drive system to ream during the stand. Control the penetration rate. Use all solids removal equipment efficiently. Be prepared for shaker screen blinding. On floaters, stroke out the compensator as far as the heave permits. Clean out the hole before drilling ahead. Avoid excessive periods of circulation opposite these formations. Wipe each connection. Avoid excessive surge or swab pressures. Be prepared for loose fill when running to the bottom. To free the pipe, circulation must be established, with concentration on working the string downwards to disturb the bridge. In addition to this, it is important to increase the applied forces gradually. Once free, ensure that material is removed from the wellbore before drilling ahead. Consider raising the mud weight if conditions allow. Mobile formations, such as flowing salt, exist in a plastic condition. When drilled, any restraining forces are removed, and overburden from the adjacent formation causes the salt to flow or ooze into the wellbore. Continued invasion of this kind can result in contact with the drill string, causing it to slowly jam, as it is squeezed by the salt. Some clays and coal can also be plastic and will therefore have the same effect. Let's look at that again. To avoid stuck pipe in mobile formations, the following action should be considered. Recognize the significance of reaction time. Perform regular wiper trips. When tripping in, slow down in advance and be prepared to ream. Condition the mud prior to penetrating the formation. Consider the use of eccentric PDC bits. Consider increasing the mud weight if the situation allows. Minimize open hole time. To free the pipe in this situation, it's important to establish or improve the circulation by applying forces gradually. In the case of squeezing salt, if circulation is possible, spot a freshwater pill while working the pipe. Do not delay in pumping the pill. Water pills should be large enough to cover the stuck point with 3 cubic meters left in the string. In oil-based systems, pump a water detergent spacer ahead of the pill. Maintain maximum pull on the pipe while the pill is circulated. And if the pipe is not free in 1 hour, repeat the procedure. Be sure to remember any well control implications. If circulation is possible, an increase in mud weight should be considered. When drilling formations which are naturally fissured, or in the vicinity of a fault zone, such as limestone or shales, pieces of rock may break off into the wellbore, jamming the drill string immediately. These pieces can vary from quite small to the size of a boulder. Let's look at that again. To avoid stuck pipe in fractured formations, the following action should be taken into consideration. Clean out any excess fill before drilling ahead. Check condition of the hole before drilling too far ahead. Clean out the annulus at a slow, controlled rate, remembering the lost circulation potential. Minimize surge pressures and restrict tripping speeds. Run a jar in the upper BHA. Be prepared to wash or ream when tripping in. Design the BHA to minimize the risk of ledge formation. In this situation, the string must be worked up and down to disturb or break up the obstruction. In addition to this, should the annulus not be packed off, apply large forces from the start of any freeing attempts. If fractured limestone is causing the problem, consider pumping an inhibited hydrochloric acid pill if available. The maximum time for such a pill to work is 2 hours. If possible, spot an acid pill with a large water spacer. And remember that if acid is used, comply to Statoil safety procedures for the handling of corrosive fluids. When drilling through geopressured formations, it's possible that the rock may cave into the wellbore. The loose material may pack up as the drill string trips out, causing it to jam. Let's look at that again. Cavings may be caused by pore pressure exceeding the mud hydrostatic pressure, or underbalance, and when produced in this way, they tend to be sharp, splintery and curved. But cavings can also be caused by formation stress, which is relieved when drilled. In this case, their shape is markedly different. To avoid stuck pipe in geopressured formations, the following action should be taken into consideration. Take time to clean the hole. Inspect the shakers for evidence of cavings. Increase the mud weight if the situation allows. Ream each single. Perform regular wiper trips. Observe pump pressure trends to identify annulus overloading. Control the rate of penetration. Minimize open hole time. Recognize increasing overpull trends and stop drilling until the hole is clear. Ensure mud specifications are maintained. To free stuck pipe in this situation, circulation should be established slowly, together with downward movement of the pipe. In addition to this, it's important to increase the applied forces gradually. If circulation is established and hole conditions allow, increase the mud weight. Certain formations, such as gumbo shales, which contain a large amount of bentonic clay, can react with the mud filtrate, causing it to swell and subsequently invade the wellbore. Continued invasion of this kind results in clay balls and mud rings, which can build up and eventually make contact with the drill string, causing it to jam. The potential risk for stuck pipe is increased as the pipe is tripped out and the BHA becomes trapped by the mud rings. Let's look at that again. To avoid stuck pipe in reactive formations, the following actions should be considered. Avoid long periods without circulation whilst the BHA is below the problem area. Whilst drilling, be prepared to stop and clean the hole. Plan regular wiper trips. Recognize the potential increase in swab or surge pressures. Be prepared to ream or back ream whilst tripping. Recognize any changes in mud properties. Ensure mud specifications are maintained in advance. Wipe the hole regularly while drilling. To free the pipe under these circumstances, full circulation must be established by working the string in a downwards direction. In addition to this, it's important to apply the freeing forces gradually. If circulation is established, an increase in mud weight may be beneficial. When drilling deviated or curved holes, the drill string tends to be forced against the borehole wall. Continuous pipe rotation starts to cut a groove, or key seat, especially in softer rocks. Further rotation will result in a mature key seat, a cross-section of which looks like this. When tripping out, drill collars or stabilizers can easily become jammed, especially where transitions between hard and soft rock combine with severe doglegs. Let's look at that again. To avoid stuck pipe caused by key seating, the following action should be taken into consideration. Minimize pipe rotation at the same point. Perform wiper trips. Minimize dogleg severity. Consider the BHA design or configuration. Minimize the length of the rat hole below the casing. Consider installing a wiper or string reamer. Attempt to cure the problem before drilling ahead. To free stuck pipe in this situation, the pipe should initially be worked or jarred downwards whilst attempting to rotate. In addition, the following points should be noted. When free, concentrate on working the pipe upwards gradually. Avoid jamming the string into the key seat. Try to rotate the string up and out of the key seat with minimum tension. If a string reamer or key seat wiper is installed, attempt to remove the key seat by back reaming. It's important to remember that immediate working is required to reduce the risk of wall sticking. When drilling long sections of abrasive formation such as sandstone, the gauge protectors on the bit will become worn and ineffective. This results in the well bore becoming increasingly narrow. If care is not taken when tripping in, the new bit can become jammed in the under-gauge hole. Let's see that once more. To avoid stuck pipe in an under-gauge hole, the following action should be taken into consideration. Always gauge the bit and stabilizers and other full gauge tools accurately when going in and coming out of the hole. Ream back to the bottom if a problem is suspected. Never attempt to force the bit to the bottom. Select bits with good gauge protection. Be careful when running PDC bits after tricone bits. To free the bit, it is necessary to jar it in an upwards direction using maximum force. High doglegs can result in drilling assemblies becoming stuck, especially if they are locked up. When tripping in, the drill string is in compression, making it more flexible. Whereas when tripping out, it's in tension, which makes it more rigid. As a result, the string can get stuck in any ledges which may have formed at strata boundaries. Let's have a look at that again. To avoid stuck pipe which has been caused by the wellbore geometry, it's necessary to minimize any doglegs, minimize BHA changes, anticipate reaming if the BHA configuration is changed, simplify the BHA configuration, consider a hole opening trip. Do not run stabilizers above the jar. If hole problems are experienced when tripping in, concentrate on gradual upward working. If hole problems are experienced when tripping out, apply upward forces gradually to avoid jamming the string further into the borehole wall. If ledging is suspected, induce stress reversals by upward or downward working or jarring. To free the pipe, it is essential to jar it downwards with maximum force and to rotate it. Generally speaking, poor hole cleaning results in overloading the annulus, but in deviated wells, it also results in the formation of cutting beds on the low side of the hole, especially when the hole angle is between 45 and 70 degrees. The cuttings may migrate slowly up the hole in a manner similar to sand dunes, and when tripping out, they may pack off behind the drill string, causing it to jam. Poor hole cleaning will occur as a result of uncontrolled penetration rate, incorrect mud properties, insufficient circulation time, and insufficient annular velocity. Let's see that again. To avoid stuck pipe caused by poor hole cleaning, it is essential that we ensure that the penetration rate is controlled to facilitate optimum hole cleaning. Do not limit circulation to bottom up. Ensure that the shakers are clean. Maintain a check on the cuttings volume changes at the shakers. Maintain correct mud specifications. Maintain programmed annular velocities. Recognize the significance of increasing overpull. On semi-submersible rigs, use a riser booster line. Always reciprocate and rotate the pipe while circulating. Select the recommended viscous sweeps. Recognize the significance of hole deviation. Consider back reaming out of the hole. Plan regular wiper trips. To free the pipe in this situation, it's necessary to establish circulation and to apply downward working forces gradually. In addition, these other points should be considered. Once circulation is established, attempt to disturb the cuttings. Use high or low viscous pills depending on the situation. For example, hole angle, hole depth, hole size, hole temperature. Once circulation is established, attempt to rotate the string to further disturb the cuttings. Any objects which fall into the well from the rotary table can quite easily jam the drill string. Even a PDC cutter, for example, is large enough to do this. Consider the clearance between a 9 5/8 inch 47 pound per foot casing and an 8.5 inch stabilizer. Let's look at that again. To avoid stuck pipe caused by junk, the following action should be taken into consideration. Only use equipment which is in good condition. Inspect equipment regularly. Be careful when working around the rotary table. Leave the hole covered as long as possible. Install a drill pipe wiper on the hole whenever possible. To free the pipe, emphasis must be on upward and downward working or jarring to dislodge the obstruction. In addition to this, it's important to gradually increase the applied freeing forces. When drilling with the casing in position through plastic formations, such as salt, it's possible for the forces exerted by the surrounding formation to exceed the casing collapse pressure. This can result in damage or deformity to the casing, which can jam the string or BHA, especially when tripping out. This usually occurs when the casing is too light, or when it is too old, which effectively reduces its grade. Or indeed when the casing is landed with too much tension, which reduces its collapse rating. Let's look at this again. These cases cannot be dealt with by rig personnel alone, since specialist tools and procedures are required to free the drill string. Furthermore, collapsed casing can easily result in side tracking. When cleaning out a rat hole or a cement plug, it's possible for chunks of cement to break away and fall into the well bore. One or more of these chunks may well be sufficient to jam the drill string. Let's look at that again. To avoid stuck pipe caused by cement blocks, the following action should be taken into consideration. Minimize the rat hole below the casing shoe. When drilling casing rat holes or cement plugs, always ream the section thoroughly before drilling ahead. Beware when tripping back through the casing shoe or past cement plugs. To free the pipe, alternate upward and downward working must be applied slowly to dislodge or break up the obstruction. In addition, it's important to gradually increase the applied freeing forces. When drilling out or dressing off a cement plug, or when cleaning out after cementing a liner, it's possible that green cement may lie undetected in the hole. When running in, the drill string can become planted in the cement. If the cement flash sets under pressure, then it's quite possible for the drill to become stuck. Let's see that again. To avoid stuck pipe caused by green cement, it's essential that you pre-treat the mud if green cement is suspected. Know the theoretical top of the cement. Begin circulating well above the theoretical top of the cement. Check for cement returns at the shakers. Do not rely on the weight indicator. Restrict the ROP when cleaning out cement. In this case, immediate action is required. Apply maximum force from the start of the freeing operation and concentrate on upwards working and jarring. Attempt to establish circulation. When drilling through permeable formations, the pressure exerted by the mud column is greater than the pressure of the formation fluids. As a result, a filter cake will build up in the wellbore. Continual build-up of the cake will result in contact with the drill string. Any part of the string which is embedded in the cake will be subject to a lower pressure than the rest of the string. If the pressure difference across the filter cake is high enough over a large enough area, then the pipe may become stuck. Let's look at that again. To avoid stuck pipe caused by differential sticking, it is necessary to maximize the string movement. Rotate the string on connections. Always begin pipe motion in a downward direction. Ensure pit space is available for pumping pills. Use spiral DCs. Minimize the length of the BHA. Avoid surveying methods which can result in the pipe remaining static for long periods. Consider using undergauge stabilizers in the drill string. Keep the mud in good shape to reduce fluid loss. To free the pipe in this situation, it's necessary to work or jar the pipe downwards and apply right-hand torque. Additional action might be to begin working the pipe immediately and apply maximum forces from the start, as time is a critical factor. Consider reducing the mud hydrostatic. Reduce the mud weight if acceptable. It's important to remember any well control considerations and the effect of reduced hydrostatic head on formation instability elsewhere in the wellbore. In general, it is possible to define these rules of thumb when experiencing stuck pipe. If the string becomes stuck while being moved in one direction, it should be worked in the opposite direction. Begin working the string immediately, and if possible, use the jars by jarring in the opposite direction to the pipe movement before becoming stuck. And remember, immediate working of the string may not free the pipe, but it may help to prevent additional sticking. Work the pipe to the limits. The tool pusher must ensure that a maximum safe pull is specified for each assembly run. When working the string, reference the working weights to the free point weight, which is determined from our stretch data, as well as the normal hole drag, which is determined from our experience of the well. If downward movement is achieved, concentrate on expanding that movement. If circulation is not already established, attempt to establish it as a major priority. If some circulation is possible, attempt to gain full circulation. In cases of hole bridging or packing off, concentrate on downward working and increase the applied working force in gradual increments up to the maximum. Always leave enough room above the rotary table to allow the jar to be operated.
When tendencies to stuck pipe is detected, time is of the essence. Even more so if stuck pipe has occurred. This sheet can help determining the stuck pipe mechanism and therefore implementing the corrective actions sooner. Cross off the pipe motions, and the highest score will tell which first action to apply to counteract the situation.